Today I want to talk to you about the periodic table. This is both a review of what you should have gotten from Thursday's WebQuest and a lead into the rest of the week on periodic trends. So the modern periodic table is arranged by increasing atomic number, and if you'll recall, atomic number is the number of protons which identifies the element and is unique for each element. The periodic law states that physical chemical properties of the elements repeat in a regular pattern when they are arranged in order of increasing atomic number. So from Friday's lesson, when we look at how they're grouped, you should have seen that the metallic character is in order from more metallic to less metallic across a period, and more metallic to less across down a group, or to more metallic down a group. So the periodic law says that regular repeating patterns occur. So as you go across a period, it goes from metals to nonmetals, from solids to gases. You also have that octet rule of 8 valence electrons. So after those 8 valence electrons is where you start a new period or a new row. So a period consists of all the elements in a horizontal row. So like a period of time on a calendar is from Sunday to Saturday, left to right. And they are numbered on your periodic table, 1 through 7, which correlates to the quantum energy level of 1 through 7 of K, L, M, and O on the quantum numbers, which helps you identify the shell that the electrons are in. When you organize them by the octet rule, where you have 8 valence and then you have to start a new period, then you create what are called groups. And those elements within each group, also called a family, have similar chemical and physical properties, and they behave the same way because of their valence electrons. So if you'll recall from that periodic table where we labeled the valence electrons, group 1 has 1 valence electron. Because of that, those elements all behave very similarly. So if you'll notice on your periodic table, looking at the elements of the periods, they are labeled on your periodic table. Period 1 only has 2 elements, hydrogen and helium. We often stick hydrogen by itself because it can act like a group by itself because it is a nonmetal and it is a gas. However, it behaves like metals. Same thing with helium. It doesn't have the octet. It just has those 2 valence electrons. So once you have a full S, then you start back to a new S, a larger S in the second quantum energy level, and then go across the P block, if you'll recall the P block, and then 2 plus 6 equals 8. We have an octet. We have a full valence shell. Then we have to start a new quantum energy level of period 3. So the groups then are organized that way, and they have similar chemical physical properties, except for hydrogen because he can act like a metal or a non-metal. And then we have, of course, the elements in group 2, which allows us to see the elements organized by their valence electrons. So 2 valence. And then we call these the transitions, and they're special because they actually transition from metals to nonmetals. Hopefully you learned this from the WebQuest that you did on Thursday. And then again, group 13, 14, 15, 16, 17, 18. Okay. So metals have luster, can conduct heat and electricity. That's why we make our electrical wires out of copper, and this is why we use metal cook pots for cooking. And they bend easily without breaking, meaning they're malleable. They can be hammered into thin sheets, or ductile. They can be drawn out into thin wires. All of them are solids at room temperature. Room temperature is roughly 22 degrees Celsius or 70 degrees Fahrenheit. Except for mercury, which is that quicksilver. It's liquid at room temperature. It's really an enigma. A lot of scientists are still trying to figure out the chemical properties of mercury that makes it have the physical property of being a liquid at room temperature. The other one that you might be familiar with that maybe Miss Cup worked with is gallium, which has a very low melting point, and you can get it to melt in your hand. Nonmetals are just the opposite. They're poor conductors of electricity. That's why they make good insulators. So for example, glass, which is made of silicon and oxygen, called silicon dioxide, makes for a great insulator. Other compounds like cotton and linen, fiberglass, those are all nonmetal materials, or materials made out of nonmetals, therefore they don't conduct electricity, and they make good insulators. They don't conduct heat very well, and they are very brittle when solid. They break easily. You can't shape them and mold them. And a lot of times they tend to be liquids and gases at room temperature, and they tend to have 5, 6, 7, or 8 valence electrons. So if we compare some of the properties of metals and nonmetals, we can say that in terms of their luster, metals are lustrous, meaning they're shiny, and that nonmetals are non-lustrous, and they can have a variety of colors. And they tend to be solids for metals and easily formed or deformed, whereas nonmetals tend to be hard or soft, usually brittle. So for example, you're made of mostly nonmetals, except for a few exceptions like iron in your blood and chromium and that kind of thing. So notice you are very soft and can be brittle. Good conductors of heat and electricity for metals. Nonmetals make great insulators because they don't conduct heat or electricity very well. And the very last one is very important because we're going to use that to help us understand what an ion is later. So metals' chemical properties tend to be they have very loosely held valence electrons, and if you'll recall from Friday's lesson, it has to do with that shielding and that nuclear charge effect. And then nonmetals tend to have very tightly held valence electrons, which again is going to determine their chemical properties and their trends that we're going to talk about later this week. And again, that goes back to that shielding effect and that nuclear charge effect. So that's very important for you to remember because we use this concept, this idea of these valence electrons being loose or being tight. Then in between the metals and the nonmetals, you have properties that are similar to a metal and similar to a nonmetal, and we call them metalloids. And they are found on the stair-step line on the periodic table. And some examples are things like silicon, germanium, arsenic, and we call them semiconductors. You may have heard this term before. They are used in electrical components because they don't melt, because they have very low conductivity to heat and electricity, but yet conduct better than a nonmetal. So they're often used in computer components and other type of electrical components. So they have properties of both a metal and a nonmetal, but not quite like a metal and not as poor as a nonmetal. So you probably heard the term semiconductors before. So if we look at our periodic table, we see that hydrogen is a nonmetal, yellow is the nonmetal, and all of these are nonmetals. All of these that are blue on the stair-step line are called metalloids. And you will also find that sometimes they argue whether or not boron is, and they argue whether or not astatine and polonium are. So for the most part, it's these elements that are silicon, germanium, arsenic, antimony, and tellurium are all the metalloids. And then all of these in gray on your periodic table, including the lanthanides and actinides, are all the metals. So the idea of the periodic law, when in order of increasing atomic number, you end up creating rows and groups, and as you go across a period, then you have the octet rule, which starts a new group. So then these are all behave chemically and have similar physical properties. And then notice how they transition across to nonmetals. So the other part that you should have learned from Thursday's WebQuest, hopefully, is the names of the groups of the elements on the periodic table. So you're supposed to know that group 1 are called the alkali metals, and group 2 are called the alkaline earth metals, and that groups 3 through 12 are called your transition metals. And then you have the boron group, carbon group. This is the nitrogen group, used to be called the pnictogens group, the old terminology. And then the oxygen group, which is the old terminology, is the chalcogens. So you just need to know boron, carbon, nitrogen, oxygen. And then you do have to know the special name for group 17, which is the halogens, the salt formers, and then the noble gases. And we call them the noble gases in group 18 because they're non-reactive and they have those 8 valence electrons. And remember, all elements want to gain or lose to have 8 and be like a noble gas. Okay? Otherwise, they're very reactive the way they are because of their valence electrons. And then in these, you'll see that varies from periodic table to periodic table. Sometimes they'll put lanthanide and actinium in here, lanthanum and actinium in here, but then these are pulled out just to make the periodic table fit nicer on a page. And then those are called the actinides, and those are lanthanides and actinides. Okay.